Hello, we are Team 8. Our subject is audit comparison between different drinking straw materials. This is contents of our speech. Hi, my name is Youngjae. Today, I'm in charge of the introduction part. Let me start. Have you ever had food packaged or delivered? Or have you ever ordered a drink or coffee at a cafe? Probably no one else is. Most of the time, you will use disposables when packaging beverages. Among them, almost all straws are made of plastic because they are light, small, flexible, and very cheap. As you can see from the figure below, the use of plastic straws is increasing every year. Also, the current COVID-19 pandemic is accelerating the use of these plastic straws. But there is a big problem. In the case of plastic straws, recycling is difficult, and even if recycling is possible, most of them are buried in the ground because of the high cost. Plastic straws buried in the ground take more than 200 years to decompose. If you look at the statistical data here, you can see that various materials are used as straws, but plastic straws made of polypropylene occupy the overwhelming majority. In order to solve the aforementioned environmental problems, we have conducted various investigations so far. Various eco-friendly materials that can replace polypropylene have been investigated, but we will introduce the most ideal eco-friendly material due to time limit. It is PLA-based straws. PLA is made from 100% vegetables and is the most sustainable material in that it is eco-friendly, biodegradable, and does not release harmful substances when decomposed. So, the purpose of our project is to ultimately replace the polypropylene straw with the PLA straw through the above process. This time, let's talk about legal regulations. The European Union started to ban most plastic products from July this year, and in Korea, a law was enacted to ban the use of plastic straws in restaurants from July next year. Here are more detailed Korean regulations. Finally, let's compare the price of polypropylene and PLA. Pricing per ton confirmed that polypropylene is slightly more expensive than PLA. From now on, Minyoung is gonna talk about life cycle assessment analysis.
Thank you, Youngjae. Hello, I'm Minyoung. I'll explain straw manufacturing process and life cycle analysis. Straw is made through the processes of polymer molding, straw extrusion, special operation, and packaging. Special operation is the process manufacturing two types of straws, and then straw is packed with paper slip and box, and it is transported. Therefore, we calculate the embodied energy needed in life cycle of PLA straw and PP straw. The SSV and the calculation process in last presentation is different with the result from EdTech program due to implicit properties of internal resource. Therefore, sustainable sourcing value of EdTech is going to used and applied to entire energy calculation. For SSV, sustainable sourcing value of PP needs 69.2 MJ and PLA straw takes 55.3 MJ. SMV should be derived with molding and extrusion together, referring to the required value for each process as shown in the table. After taking calculation, it shows 1 kg of PP straws need 21.1 MJ and PLA straw takes 14.3 MJ. Next, Sustainable transport value are calculated with considering the location of a raw material production place, port, and the processing factory. Moreover, transporting method and the size of truck is essential to calculate the value. For the STV, PP straw needs 2.52 megajoule and PLA straw needs 0.167 megajoule. In the life cycle of straw, sustainable maintenance value and the sustainable usage value is zero because straws are single-use item. Last is sustainable disposal value. In Korea, incineration rate is higher than landfill rate, so we assume the end of life as combust. For the STV, straw needs the 0.5 megajoule of energy. End of this, the calculated value is summarized for the energy balance sheet. This is energy balance sheet of PP. As shown in this table, total applied energy of PP straw life cycle is 93.32 megajoule and saved energy is 11.3 megajoule. As a result, net saving energy is 80.02 megajoule. Next is energy balance sheet of PLA. In this table, total applied energy of PLA straw life cycle is 70.3 megajoule and saved energy is 4.86 megajoule. Therefore, net saving value is 65.45 megajoule. Next, Mark will present the environmental impact.
Hello everyone, this is Malte Zeppel and I want to give some information about the environmental impact. First, let me start with the environmental pollution potential. We divided it into the polypropylene and the PLA and into the topics water pollution, air pollution and soil pollution. Let me start with the water pollution. We have the possibility of oil spillage in the process of mining and transporting the crude oil, which is the raw material of the polypropylene. Also, we have the problem if an accident occurs, it poses a very serious risk to nearby water and the ecosystem. Also, the heated coolant causes great chaos in the ecosystem. Now to the air pollution. We have severe air pollution caused by exhaust gas when operating petrochemical plants. Also, the inhalation of naphtha or polypropylene shows aesthetic effects of mild toxicity. The last topic would be the soil pollution. So polypropylene is a fire hazard, and because of its volatility and flammability, it could cause serious problems. Now to the PLA. First to the water pollution. In the lactic acid production, nitrogen-containing compounds are discarded with water. Also, we have a marine eutrophication due to the use of fertilizer and manure. The next topic would be the air pollution. Chemicals used to produce lactic acid emit greenhouse gases. Also, we have the problem with the fine dust, so with some small particles, and the incineration of crops, residues, and the production of fertilizers also emit greenhouse gases. To the soil pollution, we have the soil pollution due to the fertilizer and manure, and the sulfur dioxide and nitrogen oxides emitted during the lactic acid production have a great impact also on this topic. Now to the LCA of polypropylene versus PLA. Let me start with the LCA of PLA cups, not of PLA straws, because we couldn't find any data. but because it is in percentages, the unit, and in the production is kind of similar, we also wanted to use this data. It has the same structure as the LCA of polypropylene that we were talking about later. And also the occurrences are quite similar. And when you compare it to the polypropylene, the production of lactic acid and the PLA production are the biggest impacts. When you look on the LCA of polypropylene, you can see 6 different impacts have consequences of 6 different occurrences, and all impacts of each occurrence result in 100%. The biggest impact here is the straw material, followed by the wrap material. And in most cases, it is possible to improve the balance at around 90% due to recycling and recovery. You can see this here. So now I want to hand over to the next person.
Thank you, Mart. I'm last speaker Junyoung. From now on, let me talk about our discussion. Firstly, we add something is good and poor LCA sourcing practice. For PP, it needs long distance with fossil resource and poor straw sorting system. On the other hand, there is poor PLA recycling system in Korea. However, PLA has huge recycled material opportunities that can reduce as much as 52 megajoule per 1 kilogram of PLA straw and PP straw, as shown in below chart. The corporate nature work are now progressing chemical recycling in abroad, but not yet in Korea. From now on, let me suggest our possible LCA improved practice. The reason why among all the phases of LCA, disposal has big possibility to be improved, application of the 4 R's can be possible LCA improved practice following left side waste hierarchy diagram. The avoid way, which is the most preferable, is to regulate the manufacture of straw. In UK, relevant law has been already started, and Starbucks provide the cups with plastic lid that doesn't need straw. The reduced way, which is the secondary preferable, is to reduce the opportunities of usage with education about potential dangers. Moreover, campaigns can effectively promote plastic reduction. And for example, Starbucks again, they have had campaign and event that give bonus points who bring their own tumbler. So similarly, this can be applied to not using straw event with price discount. There is last way, that is recycling. As single straw is hard to be sorted in recycling center, enact the law of bundling the straws together by tying with the string. Especially case for the PLA, by letting Ministry of Environment make new PLA recycling mark, the system can form the basis of increasing PLA recycling rate. From now on, I will sum up and give you our conclusion. In LCA analysis, PLA show better environmental impacts on embodied energy and CO2 emission. But PLA has some limitation now, so we will give suggestion to our society, that is, need of supported system including PLA recycling center and regulations. Thank you very much for listening our presentation. And please give us any question.